Computerized version of the F-16 can actually talk.
Brake, fuel, 5.6 pounds.
Advisory altitude.
The principal objective, of course, is to present the pilot with auditory information, which previously had to be read from a dial or a display. But a secondary benefit relates to G-induced loss of consciousness. If the plane believes that the pilot is diving too quickly towards the ground, it will tell him so. And if he ignores the warning or can't hear it because he's unconscious, the plane will take over and fly him to safety. Although there are myriad displays and dials which tell the pilot about the status of the aircraft, until now there's been nothing to tell the aircraft about the status of the pilot. This study, being conducted by doctors at Edwards Air Force Base in California, monitors the pilot's brain waves while he's flying so that eventually the plane will be able to judge whether the guy at the controls is awake, asleep, or somewhere in between.
And that goes right to the equipment.
The key to the system is a dynamic analysis of the different types of brain waves associated with different types of activities.
Captain Escherman, would you please gently grit your teeth for me? That's fine. Now relax your jaw. All right, now could you please close your eyes for us?
It's these longer, more regular alpha rhythms associated with a state of relaxed vigilance which are of particular interest to the doctors running the study. For 3 years, test pilots have subjected themselves and their aircraft to every stressful maneuver in the book, while having their brain waves recorded for subsequent analysis back in the laboratory. The study has amassed a wealth of data which will be published this year. But already there have been some interesting and unexpected themes emerging, not just concerning the brain's experience of G's, but also concerning that other potential killer, information overload. It turns out that fighter pilots are predominantly artists, because flying planes is a function of the right side of the brain. The left side of the brain is the administrator, checking data, establishing priorities. From time to time, the two halves check with each other that all is going well. But problems occur when that cross-checking starts occurring too often, when the brain can't decide who's in control. Combined with the physical effects of G's, this psychological overload amounts to a serious problem for today's pilots, a problem some scientists have called the biology barrier.
Perhaps even more profound in some ways than the sound barrier. We could come up with technology to resolve that problem and go far beyond it. But now we have to redesign the operator. And the decision is, do we maintain a biological operator or a silicon-based operator?
Or perhaps even both. Here at Wright-Patterson Air Force Base, engineers are working on developing smart systems that will relieve the pilot of the routine chores of flying. New cockpit layouts will present him with pre-digested information that is designed to assist him in developing what's known as situational awareness. The displays enable him to keep track of how his aircraft is performing, and should a problem occur, the aircraft will tell him about it.
Caution, fuel.
Fix it.
If only everything were that simple.
Fix the fuel. Okay. Max range?
340 miles.
This system is known as the magic cockpit. And in addition to chatting amiably in a female voice, because female voices apparently command attention better than male voices, it will show him plan views of his target and simulated 3D perspective views of his run-in. But there are some cockpit designers who'd like to go even further and abolish conventional displays altogether.
Humans are basically three-dimensional beings. We see things in 3 dimensions, we hear things in 3 dimensions, and we touch things in 3 dimensions. And what we want to try to do now is to take those things that the pilot needs to know and convey them to him in a wide field of view, 3-dimensional picture with 3-dimensional sound and 3-dimensional things that he can touch, all of which are synthesized in the computer and projected into 3-dimensional space for the pilot.
And inside what must be the zaniest helmet ever devised, this is what the pilot sees. Like some fantastic arcade game of the future, the pilot flies through a world that the computer has devised for him, based upon the known characteristics of the F-15 and its potential adversaries. In this Tron-like 3D arena, he can take off and land, navigate to preset coordinates, and he can fire his guns if need be, there is still a gun, and activate his missiles, all by voice control.
Selected.
The engineers readily admit that these futuristic concepts are likely to remain impractical for at least the next 8 to 10 years. And clearly, no pilot could be persuaded to dogfight pulling G's with a ridiculous contraption like this on his head. But it is only experimental, and advances in miniaturizing the high-resolution TV screens that will project the graphic displays onto the inside of the visor have already led to the development of a new and much more feasible flying helmet currently under test. But even more unusual ideas are being developed at Wright-Patterson. This man is switching switches simply by looking at them. Using infrared lasers, sensors in his helmet read his eye position from moment to moment so that computers can identify the switch he's looking at. And down the corridor, the tiny magnetic fields given off by the brain activity of this research volunteer are being analyzed by a superconducting device known simply as SQUID. Controlling fighter aircraft systems simply by thinking is, some researchers claim, no more than 30 years away. But if technology is making such giant strides forward, why push human pilots beyond their limits? Why risk human flesh and blood in cockpits at all?
If we were able to know everything that was going to go on in a battle, if we knew where the enemy was going to be, we knew where our friendlies were going to be, if we knew how well our aircraft was going to work, how well our weapons were going to work, it wouldn't be necessary to put a pilot in the loop because we can program a computer or a drone to go do that work. But that's not what happens in the battle. The whole battle situation engenders a sense of uncertainty. Therefore, you have to have an element in that system that can adapt, can adjust, to be able to compensate for the deficiencies of the system or perhaps some of the gaming that the enemy does. Therefore, we believe that for a long time, we're going to have a human in the loop.
Even Star Wars had a pilot in the cockpit. But air combat maneuvering is so dynamic. The human element brings flexibility that I think will actually be the key to success out there, because there's just no substitute for being on the spot, in the air, seeing who's injured, who's not damaged, who's in trouble, who's not in trouble. There's all sorts of things that a pilot can do at the scene that someone far away from the scene, remotely flying it or computer-controlled airplane, will never, ever be able to figure out.
Consequently, you still need to train to the basics of dogfighting that probably haven't changed since the days of World War I. A barrel roll is still a barrel roll, and an Immelman still an Immelman. We still do flat and rolling scissors, and we still need a gun on the aircraft to be able to shoot that guy when he's 500 feet out in front of us, which is well within the minimum ranges of all of our sophisticated missiles. But it's certainly not within the minimum range of a bullet.
Which brings us right back to where it all started. Here at Top Gun, the cream of the Navy's fighter pilots learn how to employ World War I tactics with 21st century technology against numerous but essentially low-tech foes. For years, the comment attributed to Lenin that quantity has a quality all its own seemed to be driving the design of Soviet fighters. But recently, all that seems to have been changing.
Right now, we're looking at a much more capable airplane. In this case, anyone know what this is?
MiG-29?
Exactly right. MiG-29 Fulcrum. Much more capable airplane in terms of all those performance factors we talked about earlier on.
The MiG-29 Fulcrum and its equally high-tech comrades, the Su-27 and the MiG-31, are high-performance 21st century fighters. Some say they're equal in sophistication to the F-15 and the F-14. And certainly their electronic capabilities are being viewed with envy in the West. As the Soviets move from low-tech quantity towards disquietingly better quality, the West agonizes over whether or not to shift its emphasis the other way, from technological quality towards more quantity. So where does all this leave the pilot, the guy at the sharp end? What he seems to need is reliable and appropriate machines, not necessarily the most expensive ones, that will enable him to get on with the job we're asking him to do. While there are many opinions about how to equip the squadrons of tomorrow, one thing is clear. We can no longer continue to ignore the intrinsic limits of human physiology and psychology. Technology has brought these highly educated, highly trained pilots face to face with what has been referred to in this program as the biology barrier. If pilots are to remain in the cockpit at all in the future, technology will have to find a way to overcome that barrier as well.
Tomorrow night, Sherman's march to the sea, Lee's surrender to Grant, and the assassination of Abraham Lincoln. As Ken Burns' masterpiece, The Civil War continues. TV as it ought to be. The Civil War tomorrow at 8. We hope you can watch. Stay with us now for today's Japan, next at 12:30.
Funding for NOVA is provided by Lockheed, a bold new force in systems engineering, management, and technology services for defense, space, and industry. And the Johnson & Johnson family of companies, supplying healthcare products worldwide. Major funding for NOVA is provided by the financial support of viewers like you. For a transcript of this program, send $5 to this address or call 212-227-READ.
This is PBS. Next time on NOVA.
The average time from the kids arriving in the hospital in Promisao until death was 2 hours.
A mysterious disease attacks the children of Brazil.
In the month before Tatiana became sick, did she have any other illness or infection?
Follow an international team of medical detectives as they race against time to discover what's killing the children. That's next time on NOVA. Most NOVA programs are available on videocassette. Schools, businesses, and organizations interested in purchasing videocassettes should call 1-800-441-NOVA.
Local broadcast of NOVA is made possible by our members in partnership with the Genrad Foundation, with Harvard Community Health Plan, celebrating 20 years of providing New England a better quality of life, and with Peugeot, builders of distinctive, intelligently engineered European automobiles for more than a century.